Okay, we're looking at MRS 10, number 6 through 10. Number 6. It says, which fraction is closer to 1? So 1 whole. And they give you 2/3, 7/8, 3/4, and 7/10. All right, so let's look at this one. So, we're trying to get as close as we can to 1 whole. So what I did, I just drew pictures here. And the key about when you're drawing pictures is you got to try your best to make sure each rectangle is almost exactly the same size. Okay, so try to get each one exactly the same size. It's not gonna be perfect, but try your best. And what I did is I just then took my options, 2/3, which was A, 7/8, 3/4, and 7/10, and I broke those. I made the rectangles into that many parts. Okay, so once you do that, so for example, this fraction has 3 total parts. This fraction has 8 total parts. This fraction has 4, and then this fraction has 10. So basically all I'm going to do is I'm going to follow my whatever my fraction is. So this is 2/3. So I would color in 2/3. 7/8. 1, 2, 3, 4, 5, 6, 7. So I would color all of that in. 3/4. 1, 2, 3. And 7/10. 1, 2, 3, 4, 5, 6, 7. Okay. So then once I do that, I can visually see which one is closer to 1 whole. Which one is closest to being, all the all of it filled in. Okay, and when we look at it this way, we can clearly tell that 7/8 would be closer to 1. But guys, make sure you're showing your work when you do this. So don't just copy the answer 7/8. You have to show how you got your answer. And drawing pictures is an easy way to do that. If you need to, just do it on a separate sheet of paper. Okay, number 7. Says each side of a square office is 3 meters long. It will cost $25 per square meter to replace the carpet in the office. What would be the total cost to replace the carpet? Okay, so let's look at this one. All right, so it tells us I just drew a picture of a square, which represents the office, because it said each side of a square office is 3 meters long. So I just put 3 meters here, 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 and here, because it told me it was a square office. It says it will cost $25 per square meter to replace the carpet in the office. What would be the total cost to replace the carpet? So what I have to do first is I have to find the area of this office. Just like if you were finding if you were replacing carpet in your house or hardwood or whatever's in your house, you would have to find out the area of your floor of whatever room it is in order to know how much to buy and how much it was going to cost. So this is kind of the same type of question. They want to replace the carpet. In order to replace the carpet, you have to find the area of the room. Okay, so it says I just wrote the question, what is the area of the office? Because that's the key thing we have to figure out is the area. How much area is in that office that we're going to have to buy carpet for? So that we find area, here's the formula. You multiply the base times the height. Base times height gives you area. So in this problem, it's pretty simple because all of these are 3 meters. So my base is 3 times my height, which is 3. Okay? And that would give me the area. So in this case, the area is going to be 9 meters squared. Now you did that from just multiplying these two numbers together. Okay, but I'm not finished yet. Once I get this number, I know each square meter costs $25. So it's $25 for 1 square meter. Okay, so it's 25 for one of them. I have 9 of them. So I'm going to have you determine what would you do to determine how much all 9 would cost. So again, $25 is for 1 square meter. I need to know how much 9 would cost. So think about operation. What operation would you use that would make the most sense in order to find out how much money it would cost for all 9 square meters? Okay, so I'm going to have you figure that part out on your own. Again, you need to find out how much it's going to cost for 9 square meters. Okay, and just to give you an idea, it would cost $25 for another square meter. So that would be 2. Okay, we're already at 50. And if I just kept doing that over and over and over until I got all 9 down, what would be the easiest way to figure that out? Okay, you can do that part on your own. All right, let's look at number 8. It says Reuben buys a 3-pound, 4-ounce bag of apples. How many ounces are there in 3 pounds, 4 ounces? So this is another one of those conversion problems. Okay, so we have 3 pounds, 4 ounces. I know that here's the key. I know there are 16 ounces in 1 pound. Okay, so how many ounces would there be in 3 pounds? So again, just like the last problem we were doing with the $25 and how much it would be for 9, same thing here. I have 16 ounces in 1 pound. So how many ounces are in 3 pounds? Okay, so 16 ounces. We'll just help you out here. 3 pounds. So again, I know there's 16 ounces in 1, so I need to figure out how many are in 3. So I am going to multiply this. You do the multiplication. That will give you this answer. Okay, but now we are not finished once you get this answer, because we still have to add on the 4 ounces. Okay, so we figured out how many ounces are in 3 pounds, but now we need to figure out, once we get that answer, we have to add on that extra 4 ounces. So I'm just going to put a plus 4 here, and then this will be your final, and then that'll be your final answer right here. Okay, so just a quick review. I know there's 16 ounces in 1 pound, so therefore I need to figure out how many ounces are in 3 pounds. To do that, I'm going to multiply 16 times 3. I'm going to get that answer. Then I'm not finished, because I have to add on the 4 ounces. That's with the 3 pounds. So once I get my multiplication answer here, I still need to add on 4 pounds to it, or excuse me, 4 ounces to it, and then that will give me the final answer. All right, next problem, number 9. It says, what is the name of the right angle? What is the name of the right angle? And so the angle on your review sheet looks something similar to this. Okay, so the first thing I have to do is identify the right angle. Okay, and remember, for a right angle, I like just to think of it as an L. You know, it could be that way, but it doesn't matter which way. It could be this way. It could be any of those ways. Just so it has that 90 degree angle. So looking at this, okay, we'll just go ahead and do this one together. I can tell that my right angle is right here. Okay, that is my right angle. Okay, so what I need to do now, the question is, they want us to name the right angle. Now we can do this in several different ways. So we'll go through each one, because this is maybe a while since you've seen this. So I know this is my angle right here. That's my right angle. Okay, so the first way, and this is important that you label it correctly. So this represents angle. So this represents angle B, C, D. Okay, I could do it that way. Or I can say angle, I could go the opposite way. D, C, B. Okay, and there's one other way, or I could just name the vertex. angle C, which is right here, the vertex of that right angle. Okay, so you have to have it all three ways, because I can name it all three ways. Well, I'll take that back. I'm not sure if they want all three ways, but it wouldn't hurt to put all three ways, just so you get in the habit of doing it. So I can have angle BCD. That makes the right angle. Or I could say angle DCB. That makes the right angle. Or I could just say the vertex angle C. Okay, make sure you put that angle symbol as you're naming it. Okay. And the last question, number 10. Rob was driving his car 63 miles per hour, which is 18 miles per hour faster than most pigeons can fly. How fast can most pigeons fly? So again, he could drive his car 63 miles per hour, which is 18 miles per hour faster than most pigeons can fly. So, let's look at this. Okay, so he's 63 miles per hour again. That's 18 miles faster than a pigeon can fly. So, how are we going to determine how fast the pigeons can fly? All right, we know he can go 63, but we know that's 18 miles per hour faster than what pigeons can fly. Okay? So, I'm not going to tell you the operation on this, but when you do this, I want you to make sure you're thinking about what would be the best operation. For example, I know that if I ask you the question, who is faster, Rob or the pigeon? You should know that answer because it says that the Rob is 18 miles faster than pigeons fly. So obviously Rob is faster than the pigeons. So if you start to do this problem and you say 63 plus 18 is 81. So you're saying that pigeons can fly 81 miles per hour. You know that that should not be the correct answer because you know that Rob's faster than the pigeons and Rob only goes 63 miles per hour. So again, as you're doing this, make sure you're thinking about what would make the most sense in this situation operation-wise. Okay, so if we added here, obviously the pigeons cannot go 81 because Rob only goes 63 and he's faster than the pigeons. So I'm not going to do this one. I'm not going to tell you which operation to use. I want you to figure this one out on your own. You can do it. And just make sure your answer makes sense. Make sure your answer makes sense.